So in this video, I'm going to introduce polynomials. So polynomial number one, it's an algebraic expression. Number two, so what does it mean to be an expression? There's no equal sign. All right, it's just like 3x squared. That's a algebraic expression. Number two, the number multiplied by the variable raised to positive integer exponent. Right, so a number, that's that 3 right there, raised to some positive integer exponent, that's that 2 right there. Okay, what else? 3, we write in descending order. Okay, so if I have something like x squared plus 3x minus 1, that's in descending order, the highest power to the lowest power. Okay, there's 2 x's here, 1 x here, and no x's there. All right, now variable is the letter x, so variable is a letter, and it's used to represent a number. Okay. Fourth property for a polynomial, there are coefficients. That's the number in front of the exponent. Okay, so 3x squared, the coefficient is this 3 right here. Okay, the number in front of the variable. Okay. Number 5, degree of a individual term. So this is the sum of exponents of the variables. Okay, so like 3x squared, I look at how many x's there are. Well, if I write that out, that squared tells me that there's 2 variables, right? So that means that this has a degree equal to 2. Okay. If I had something like this, 5x squared y cubed. Now, sum of the exponents of the variables. Well, how many variables are there? This is 5 and then xx and then y. So how many total variables are there? There's 1, 2, 3, 4, 5 variables. So this is a degree 5. Okay, how do I know? I sum my exponents. 2 plus 3 gets me degree 5. All right, now don't get tricked up by seeing that 5 in front. That has nothing to do with it. That's just a coefficient that I made up for this problem. Okay. Last property, the degree of a polynomial. Now the degree of polynomial is the largest of the degrees of the individual terms. okay? So like say I had, x squared minus 3x plus 1, okay? If I look at the degree of this individual term here, it's a degree 2. The degree of this term here, well, there's only one x, so the degree is equal to 1. What's the degree of this term here? Like there's no x, is there? So there's no x, right? So what's the degree there? The degree for a constant term, like just 1 or 5 or 17 or pi or whatever, is equal to 0. Okay, it's just a constant. Now technically, you've got this x to the 0 factor to the side, and if you remember, x to the 0 is just equal to 1 as long as 0 is not equal to x. Okay, so you can think of it that way. There are no variables, no meaning 0 variables, thus your degree 0 for that constant term there. Okay, so that's kind of the trick. And so monomial, right? Monomial means that there's one term. Okay, so like 3x squared is a monomial. Binomial is two terms. So like 3x minus 5y, that's a binomial. And then polynomial, actually we're going to do trinomial also. So trinomial, 3 terms. So like x to the 3 minus 2x plus 1. That's 1, 2, 3 terms. That's a trinomial. And then poly is 4 or more terms. Okay, poly means many, so polynomial, that's 4 or more terms. Okay, so some finite number of terms. All right, so now that I've introduced to you what polynomials are, let's just do some examples. So say I have an example, 13x squared y to the 5th minus 4y cubed plus 11. Okay? Is this a monomial, binomial, trinomial, or polynomial? Well, there's 1, 2, 3 terms, so it's a trinomial. 3 means trinomial, T, right? Okay, 3. Now, if you are asked to find the coefficients, the coefficients are the numbers in front of the variable, all right? So what are those numbers? That's 13 and negative 4. 13 and negative 4. Now, why does 11 not count? Well, there's no variable next to that 11, right? But we do have a fancy word for that 11 over there. It's never changing. It's a constant. So if you're asked to find the constants, that's the one without the variables. That's 11. Okay. So let's see. Anything else? Yeah, we can do the degrees. So the degree of each term. Okay, so the degree of each term. This is a degree. Well, there's x, and then there's y. So that's 7 total. So the degree here is 7. Okay, what about this one? This is a degree 3. And this is a degree, well, if it's a constant, there's no variable. So there's 0 variables there. Okay? So those are the degrees of each term. 7, 3, and 0. Now, say I wanted the degree of the polynomial. which in this case is a special type. It's a trinomial, all right? Well, I look at the degrees of each, and I say, which one's the biggest? The biggest there is 7, so it's a degree 7, okay? The biggest degree is the one that determines the degree of the entire polynomial. So we look through each of the terms, and whichever term has the largest degree, then that's the degree of the polynomial. All right? Now, is it written in descending order? Well, descending order, we start with the biggest. So descending order. The largest is degree 7, check. Then degree 3 and degree 0. So it is written in descending order. So we didn't have to do anything there. We didn't have to move anything around because it goes from degree 7 to 3 to 0. So we're getting smaller each time. Okay? So we're good to go for that. All right. Now, sometimes you might run into a weird one, and it's like 25. Okay? So say I want to know, is this a polynomial, monomial, binomial, trinomial? Well, there's just one term. That's a monomial. It's a monomial. The degree for the term, well, how many x's are there? You see any variables? No, so the degree is equal to 0. So the degree of that monomial is 0. Do we know anything else about it? Coefficients? There's none. Okay, there aren't any coefficients, no variables, so no numbers in front of the variables. Now, constant? Yeah, the constant is 25, so that's it. That's all there is, right? It's just 25. Okay, so kind of easy, but also tricky there. So don't let that one trick you up. The degree is 0. Okay, a lot of times I see students, they put the degree as 1, so don't do that. Degree 0. All right, let's do this. 6x to the 4th y plus 3x squared y squared plus x y to the 5th. Okay? So when I look at this, I want to write this first. Let's write it in descending order. The degree here, how many variables? There's 4 x's and 1 y, so that's a degree 5. Here we have 2 x's and 2 y's, so that's a degree 4. And then here we have 1x and 5 y's, that's a degree 6. So in descending order, it's going to be x y to the 5th plus 6y to the, or x to the 4th y plus 3x squared y squared. Okay? And now that I have this, I'm going to look and I'm going to determine the coefficients. Now the coefficients are, well, it looks like the numbers in front of the variables are 6 and 3. But what about this one up here? There's no number in front on that x, y to the 5th, but it's understood that there is a 1. There's implicitly a 1 here. Okay, so just because you don't see the number doesn't mean it's not there. So if there's no number in front, it's understood to be a 1. All right. Now there's a special type of coefficient that becomes more important later on in the class, but we're going to go ahead and introduce it just in case you run into it. And it's called the lead coefficient. Now the lead coefficient, or the leading coefficient, might be what they say. So leading coefficient. Now what is the leading coefficient? This is the coefficient that is in front, is the coefficient to the highest degree term. So which term has the highest degree? Well, it's this degree 6 right here, and that lead coefficient there is 1. So for this problem, the lead coefficient is 1. Okay? So if you're asked to find the lead coefficient, that's all you do. For that problem, for that problem right here, the lead coefficient was 13. So lead coefficient is 13 for that problem, right? So you just look for the highest degree term and then go from there. All right, so anything else? Let's see. Constants, any constants? No constants because each term has variables. It is 1, 2, 3, so that's a trinomial. Okay, the degree of the trinomial is the degree of the largest term. The degree of the largest term is 6, so that is a degree 6 trinomial. Okay? All right, sometimes it's good, though, to look and see what examples that are non-examples, so things that are not polynomials. So 5x minus square root of y. Why is this not an example? Well, square root, it's understood I have a 2 here, and how many y's are inside? It's 1. So I have 5x minus, and this becomes, in radical notation, I'm going to convert to rational notation. It's rider on top, horsey underneath, right? You can go check out that rational video if you're forgetting that. And so what do we notice? Why does this fail the polynomial? Because it's not a polynomial because the variable is raised to a non-integer value. 1/2 is not an integer. So not an integer. Integers are like... It's not only just not an integer, it's not a positive integer. So positive integers like 1, 2, 3, 4, 5, 6, on and on and on, right? So those are positive integers. All right, so that doesn't work. Another example, you might have like 20 over x plus x squared. Why does this not work? Well, x here is in the denominator. If I flip it up to the numerator, this is to a power 1, but doing the reciprocal, what's that going to do to the exponent? It turns it negative, so I have 20x to the negative 1, okay? And then plus x squared. The x squared is fine. It's this part right here that's our issue. Can't have, this is a negative integer, okay? So that's not going to work there. That's not a polynomial. The last example, well, I got a couple more, but we'll just do this one. 2 to the x plus 1. Why is this not a polynomial? Well, if you notice, I mean, it looks similar, but this is actually the opposite. Instead of the base being the variable and the integer being the exponent, we've swapped it around, and this is actually an exponential equation, or expression, rather. Okay, exponential expression. Now, I talked a little, I kind of hinted at this a little bit, and we'll talk about this later, but an equation is when you have an equal sign in it. Okay, it's different than an expression. That'd be like 2 to the x plus 1 equals 3 or whatever, okay? That would be an example of an equation. Okay, an expression, you just have some expression written there, okay? That's all there is to it, no equal sign for expression. All right, cool. Good luck.